Hi, my name is Sean May. I am the owner and principal architect for Dynamic Technical Solutions. Thank you so much for joining me. Today, we're going to be talking about how to design a project as well as two important elements involved in any sort of IT project, whether you're building it brand new or troubleshooting. Knowing these two critical elements will help you in any project that you're involved in. Let's get started here. So the first thing that I'm going to talk to you about is function. Whether we're referring to, say, design or function, you can really intermix these two. Design is analogous to function. Design is the most critical element in any kind of project, meaning what are we looking to achieve? How do we want this thing to work? Where do we want it to go? In function or design, it's important to capture the requirements from these different areas. Let's take, for example, operations. You have this entire department devoted to supporting your staff. Operations wishes to lower their costs. How much does it cost to maintain the computing environment? Take, for example, they want to reduce how long it takes for someone to connect to their mobile device, get in there, and begin to be productive. That would be a functional or design requirement. How could we do that? Maybe there's application requirements. Who wishes to deploy a brand new line of shoes and they want to associate an application with that in order to, say, do online ordering. It needs to hit this certain PCI requirement, budgetary requirement, operational needs. It must have an online application. It must be secure and it must be highly available. There are certain requirements that must be met. There are nice to haves, and then there's critical things that need to actually happen. So if you have these different requirements, how do you determine which one is critical versus not so? That perfectly resides in your functional requirements that you set forth. Understanding your function and your design deliverables is absolutely key to help others align with what you're attempting to achieve. Having functional and design requirements documented, understood, and prioritized is critical to any project. After you have a very well laid out design, we've laid out how we functionally want it to work. We have our security elements, we have our operational elements, we want to reduce costs, we want to make it easier, we want to make it highly available. We have a lot of diagrams that all looks fantastic. Now we have to put it into practice. Your next significant step of the project is around structure or the mechanics. That's kind of like a phase of the project. So you have your function, the design of it, and then you have the second phase, which is your structure. That's how you implement it. Putting it into practice or actually use is really your mechanical step of a project. It's where you put it into use, where you're really going to test this thing out to make sure it functions or works how you think it's going to. Next, this is where you're going to take your theories to verify that's how it actually works. Take, for example, if an IT project, you want to make something easier on a mobile device. That's where you're pulling the mobile device out, putting the application on there, putting the security requirements on there, folding it all up, putting it up into the cloud, and making sure that it works. Now, in not all cases when you're taking a functional requirement, is it always going to line up to the mechanics or the technology. It needs to be highly available in these three circumstances. Well, let's say the country doesn't have those options. So a significant cost savings comes into identifying where you run into a roadblock with structure, where the mechanics simply do not work. It simply doesn't function that way, but they're trying to squeeze in a design element. They're trying to make this function or the design work here, and it just simply does not. The structure doesn't always align with design. In the cases where your structure does not match your functional or design requirements, when some element does not work or doesn't prove out, maybe in a lab environment, through your testing, etc., you have to reset back up to function and get alignment in that area and look at those functional requirements. When you are resetting back up to your functional requirements, that higher level of function or design, analyze where the structural or the mechanics failed. A significant cost savings element is to reset back to design when structure has failed. So rapidly resetting back to design will save you a lot in costs, especially when you have engineers sitting there spinning and spinning and spinning their wheels and frankly getting lost. Two key ways to ensure a project goes well is understanding your design and functional section of the project, and then your actual implementation or your structure, the mechanics. How does this all fit together? If If your engineers are implementing something and it's not quite working, or it's going off your timelines, it's not hitting particular targets, go back and look at your function and your design requirements. In summary, function drives structure. Keep those two apart, understand the differences between them, and have a successful project. Thank you so much. If you need any assistance, please contact us. You can find our number at the bottom of the screen here. Take care.